Hello, in this video, I will explain to you on how to solve this problem. Let's read the problem first. Figure 5.15 shows an arrangement in which 4 discs are suspended by cords. The longer top cord loops over a frictionless pulley and pulls with a force of magnitude 98 Newton on the wall. Okay, maybe let's draw that first. So we will have this pulling up with the force here of 98 Newton, right? And because this pulley is frictionless, we will have this F here also goes there. We will have 98 Newton. Okay, and then we are given the value of T1, T2, and T3, and maybe let's label the force here. So we will have T1 here that will be pulling A down, but that will also pulls B up, right? And the same for T2, it is pulling B down but pulling up C, like that. And then for T3, it's also pulling C down, but also that is pulling D up, like that. Okay, and what we need to do is we need to draw free body diagram. Draw a free body, we have 4 of them. Free body diagrams. Okay, let's start from the disc A here. Okay, what force that works on disc A? We have F there pulling up, right? So we will have our F here pulling up, and then what else we can get? We also have another here, the pulling down here. It's pulling down by T1. Okay, but also it has our own weight, so we will have the weight of A, so the force by weight of A. Good, that is free body diagrams for the disc A. Now let's move on to the disc B. Okay, and what force that work on B? We have T1 here pulling up, right? So we will have T1 here pulling up, but then we also have here T2 pulling down, so we will have T2 here. But we also have the weight of the disc B, right? So I will have the force by the weight of B. Good, and that is for the disc B. Now let's move on to disc C here. Okay, so we'll have C here, and here we also have T2 here pulling this up. But then I will have T3 pulling it down. So we'll have T3 here pulling down, but then it's also have its own weight, so I will have the force of weight C. Good, and we need one more free body diagrams here, and that is on the disc D. Good, now we have T3 pulling up like this, T3, and the only force that pulling it down is the weight of D. So I'll have F weight of D here. Good, and now we have 4 free body diagrams, but I think the simplest one here is on the disc D, right? Because we only have 2 forces here. So in the disc D here, maybe at disc D, we will have the sum of the force, and because it goes to the y direction, that will equal to the mass multiplied by the acceleration. However, because that is in stationary, so this will equal to 0 because of that is stationary or not moving. And then we will have T3 pulling up, so we will have T3, and then minus the mass, I mean the force that pulling it down is the weight of D, and that will equal to 0 here. Or we can rewrite the weight of D here as the mass of D multiplied by the gravity, right? So we'll have that will equal to 0. Now we can plug the values. What is T3? T3 is 9.8 Newton. So I will have T3 is 9.8. And then minus, we will have MD. MD, we have not known it yet, but we know the gravity, right? The gravity is 9.8 meter over second square. And all of that will equal to 0. And now we can manipulate this mathematically. So I'll have 9.8 is equal to 9.8 md. So we will have md here is equal to 1. And what is the unit? Because all the unit is in SI unit, this will be also in SI unit. So I'll have kilogram here. So the mass of D here is equal to 1 kilogram. Okay. Now let's move on to the other disk, which is disk C. Okay, now let's see the disk C at C. And again, we have the Newton's law here. The sum of the force in the y direction, because there is no force in the x direction, right, is equal to mass multiplied by the acceleration. But here it is stationary, so I will have 0, right? And then I will have T2 here pulling up, so I will have T2, and then minus, I will have T3 pulling down, so I have T3 here, and also I will have the F of weight C, the force by this mass of C, so I will have it's equal to 0. And now let's plug that in. I will have T2 here is 49 Newton. Okay, so I have 49. And then what is T3? T3 is 9.8. So I have 9.8. And then the force by the weight is, I will have the mass of C multiplied by the gravity, right? So I have all of that will equal to 0. And what is 49 minus 9.8? I think I will need calculator. 49 minus 9.8. Okay, I will have 39.2. So I have 39.2, and then I will have minus, what is MC? We have not known it yet, but we know the gravity. Gravity is 9.8. So I have MC here as unknown. Okay, and let's isolate this. So I have 9.8 MC is equal to 39.2. And now we will have the mass of C, which is 39.2 divided by 9.8, which is, I think that will be 4. Yeah, that will be 4. And the unit here will be in kilogram. So the mass of C here is 4 kilogram. Good. And now let's do same game again, but this time at B. Okay, now let's do it at B here. Okay, and we will have the sum of the force in the y direction, because we don't have any force in the x direction here, is equal to 0. Why? Because it is stationary, it's not moving, so the acceleration will be 0. Good. And T1 here is pulling this up, so I will have T1 here. And then minus, we will have T2 here. Good. And it also pulling down here by the weight of P. So I'll have FWP. Okay, and all of that will equal to 0. But what is T1? T1 is this value here, 48.8. So we'll have 48.8. And then T2 is 49. Okay, and then the weight of B here is the mass of B multiplied by G, and the G is 9.8. Okay, and all of that will equal to 0. Okay, I think I will need calculator help once again. So I have 48.8 minus 49 here, and we will have 9.8. So we'll have 9.8 minus the mass of P multiplied by 9.8. That will equal to 0. And so I will have 9.8 is equal to 9.8 mass of P. And so we will have mass of P. We can divide both sides by 9.8, and that will be 1 kilogram. Okay, so we'll have the mass of P here is 1 kilogram. Good. Okay, now we can get the last here, which is to do analysis at A. Okay, let's clean this up. Okay, now let's play the same game, but this time at A. Okay, and the sum of the force in the y direction is equal to the mass multiplied by the acceleration. And because it is stationary, the acceleration will be 0. So I'll have this will equal to 0. Good. And here, our F here is pulling this up. So I will have F here. And then I will have minus. I get this T1 here. Pulling down. And then it's also pulled down by the weight of A. So I will have F weight of A. And all of that will equal to 0. Good. So now we will have our F here, which is 98 Newton. So I'll have 98. And then what is T1? T1 is 58.8. And then I will have the weight of A, that will be the mass of A multiplied by the gravity. Right? And the gravity is 9.8, and I will have 0. Good. And I think I will need the help of my calculator once again. 98 minus 48.8. That will be 39.2. So I have 39.2. And let's move this term here to the right hand side. So I have 9.8 mass of A. Okay, and then what is the mass of A? We can divide both sides by 9.8. So we will have this divided by 9.8, and I think we will have 4 kilogram. 4 kilogram here, and that will be our mass of A. That will be 4 kilogram. And we have answered all the question, right? The masses of this A, this B, this C, and this D will have this, this, and this. And I think that's all for this problem. Thank you for watching. See you in the next video. Bye bye.